Sample problem 5.06. Forces within an elevator cab. In figure, a passenger of mass m equal to 72.2 kg stands on a platform scale in an elevator cab. We are concerned with the scale reading when the cab is stationary and when it is moving up and down. So you have to see the figure. A passenger is inside the elevator and he is exactly on the platform scale. So now we have to find the scale reading when the elevator is at stationary. What is his scale reading? When the elevator is moving upward, what is the scale reading? When the elevator is moving downward, what is the scale reading? So we have to find that answer. And here we have to answer for 3 questions, part A, B and C. So let's we answer one by one. In part A, what we have to do, find the general solution for the scale reading whatever the vertical motion of the cab. And you can see the normal force and the force due to gravity is given here, and also here the elevator has the acceleration in the vertical motion. So that means we have to equate that equation with Newton's second law. So in this situation, what we have to do, we have to consider the upward, which is equal to downward, which is equal to mass multiplied by acceleration. So let's rewrite the general equation. So the normal force minus the force due to gravity, which is mg, which is equal to Newton's second law, which is m multiplied by a. Now for getting the scale reading, we have to frame the equation in terms of normal force. So therefore the normal force Fn, which is equal to ma, and this minus mg, when it goes to the right hand side, it will take a plus mg. So by that, your normal force equation, which is our scale reading, equal to, if you take mass as a common term, you will get a plus g inside the bracket. So this is our general equation based on the free body diagram. Now we have to answer for the second question. What is given in the second question? What does the scale read if the cab is stationary or moving upward at a constant velocity of 0.5 meter per second? We studied in chapter number 2, if any object is moving with a constant velocity, the acceleration is considered to be 0, right? So in that situation, you have to take the value of a is equal to 0. And the most important thing, we have to consider the general equation which we framed in the first part. So let's we substitute the value, and also we need the mass of the passenger, which is given in the question. M takes the value of the 72.2 kilogram, and let's we write the general equation Fn, which is equal to mass multiplied by a plus g. And for constant velocity, what is the acceleration? The acceleration is considered to be 0. So now we have to find the scale reading. If the cab is stationary or moving upward with a constant velocity, what will be the answer for Fn? So as we know constant velocity means acceleration equal to 0. So when you substitute the value, we will get the answer for the scale reading Fn equal to 72.2 multiplied by 0 plus 9.8. So I have to multiply this term with 72.2 with 9.8. So 72.2 multiplied by 9.8. The answer here is 707.56. Let's round it to 708. So therefore Fn, which is equal to 708 Newton. So this is the answer of the second part. Now we have to go to the third part. What does the scale reads if the cab accelerates upward at 3.2 meter per second square and downward at 3.2 meter per second square? So that means here we have 2 cases. One is for upward motion and second one for downward motion. So for that we have to use the same equation. What is the equation? Fn, which is equal to mass multiplied by gravity plus acceleration. So this is the equation. And in chart number 2, we studied if the elevator is moving upward direction, its acceleration value is positive. When the elevator is moving in the downward direction, the acceleration of the elevator is negative. So now in place of A, if the object is moving, if the elevator is moving in the upward direction, A takes the value of positive. When the elevator is moving downward direction, A takes the value of negative, and its respective acceleration value is given in the question. So what I have to do? Let's find the answer for the upward motion. So Fn, which is equal to mass of the passenger, is 72.2 kilogram multiplied by 9.8, and it is an upward motion. So the acceleration of the elevator when it is moving upward direction, it takes the positive value. So for the acceleration, we have to take 3.2. So that means plus 3.2. So let's see what's the answer. 72.2 multiply 9.8 plus 3.2. So here I got the answer as 938.6. So let's round it to the round or single digit. So that means the rounded figure. So 938.6, I can write this number as 939 Newton. So this is the answer for the upward motion. And when we come to the downward motion, what we have to do? In place of the acceleration, we have to substitute the value, because when the elevator is moving downward direction, the acceleration of the elevator is negative. So on that basis, what we have to do? We have to take the value of the acceleration as negative. So therefore, Fn, which is equal to 72.2 multiplied by 9.8. So now this is the downward direction, so the acceleration is negative. So minus 3.2. So better I can write the information here. So for the upward motion, the acceleration of the elevator takes positive, and for the downward direction, the acceleration of the elevator takes negative. It's clear? Okay. Now let's see what's the answer for this. 72.2 multiply 9.8 minus 3.2. I got the answer as 476.52. So we can round it to 477. So therefore Fn equal to 477 Newton, and this is the answer for the question. That's it. Thank you.